Hello everyone, my name is Avikarsha Mandal from Fraunhofer, Germany. In this talk, I'd like to give an overview of the SAPPAN project and its objective. The abbreviation of SAPPAN is Sharing and Automation for Privacy Preserving Attack Neutralization. The SAPPAN project was accepted in the H2020 call SUICT 2018 on dynamic countering of cyber attacks. The project started from May 2019 and will run until April 2022. Particularly, SAPPAN concentrates on the part advanced response and recovery in cyber attack management. Some of the key challenges that are in the call that are relevant to SAPPAN are dynamically support human operators in security operations centers or CSRIT teams, help them controlling response and recovery action, including information visualization, applying best measures to withstand and recover from a threat or a cyber attack, have better protection for future attacks by applying or combining massive data or logs collected from various sources, such as network traffic, dark web, facilitated in-detail investigation on security alerts. Also effectively handling of encrypted network traffic during classification or anomaly detection where end-user privacy must be preserved. The SAPPAN expects a technology readiness level 6 by end of this project. The main objective of SAPPAN is to develop a cyber threat intelligence system that decreases the effort required by a security analyst to come with a suitable response action to recover from an attack. SAPPAN aims to achieve this using scalable, distributed, privacy-preserving threat intelligence, which allows massive data acquisition from different sources, advanced ML techniques, and shared information. In SAPPAN, we are looking at different research aspects in different directions, such as improving local attack detection, privacy-preserving algorithms for data and threat intelligence sharing, federated machine learning for improved threat detection, knowledge formalization of response and recovery action, and semi-automated or automated recommendation for response and recovery, and finally visualization and interactive support for security operation centers. SAPPAN Consortium consists of total 8 organizations. It encompasses a strong collaboration across industry, academia, and research institutes. The SAPPAN project coordinator is Fraunhofer Gesellschaft from Germany. Fraunhofer is known for transferring academic research to industry deployment. And in SAPPAN, Data Protection and Sovereignty Group of Fraunhofer FIT is contributing on privacy enhancing technologies for big data processing and for enabling and reusing knowledge related to incident response and recovery. Then among industry partners, we have Hewlett-Packard Enterprise from Ireland, and their big data experts in cybersecurity domain are contributing in high impact use cases, SAPPAN architecture design, and large-scale processing of network data. SESNet from Czech Republic, they are bringing their experience from their CSRIT team and network operation centers to provide a data and environment to evaluate the SAPPAN result. They are also contributing towards development of detection and sharing components and integrating the whole system. DreamLab Technologies from Switzerland, bringing their offensive security experience with ethical hacking, phishing, OSNIT, social engineering, auditing to contribute different analysis and specification of response and recovery use cases, designing automated and assisted response, and finally some technical validation for SAPPAN platform. F-Secure from Finland is our last industry partner, which is a global leader in providing security services and currently expanding their domain in advanced threat protection and cyber security service. And their artificial intelligence unit bringing their expertise for detection of malicious objects and contribute in automatically recommending response and recovery action and federated learning. Among academic partners, we have 3 universities, RWTH Aachen from Germany and its IT security research group have a strong background in privacy preserving protocols and machine learning based intrusion detection, and they are developing privacy preserving algorithm for intrusion detection in SAPPAN for encrypted data and contributing in federated threat detection and response. Masaryk University is our second academic partner, and they are bringing their anomaly and attack detection techniques and experience to contribute in massive data acquisition, analysis of encrypted and anonymized data, and local attack detection. Finally, the University of Stuttgart from Germany and its Institute for Visualization and Interactive Systems and Visualization Research Center, expertise in information visualization and visual analytics. To this project, they're contributing on visual front end in SAPPAN and visualization of machine learning model and for model designer and end users in Security Operations Center to support development of an improvement of comprehensibility of automated results. To start with an example, we can take a simple scenario of intrusion detection systems where networks are monitored only within individual organization, and if a suspicious patterns arises, it can trigger some alert, and that alert can be resolved by some specific response and recovery action, which is known as playbooks. And a new threat may cause new patterns. And some of the common IDS challenges are the available data and process data for the IDS is very limited, due to that, like a lot of SMEs and mid-sized companies have less IDS capabilities, and also the response time is required for new pattern can be quite long, and also it is difficult to identify attacks with new patterns. Also, there are too many false positive alerts, and security analysts might get overwhelmed, and they might get tired, and they might miss out some important attacks. And the last one is I want to say is that when you want to improve something like data sharing among organization, this also might lead to some privacy or confidentiality leakage. So in SAPPAN, we want to address this problem and contribute in fourfold. One is privacy preserving aggregation and data analysis. The second one is federated threat detection based on sharing of anonymized data and sharing of trained machine learning models. Then the third one is standardization of knowledge in context of incident response and recovery to enable reuse and sharing. And the fourth one is visual and interactive support for Security Operations Center operators. So SAPPAN has 7 objectives, mainly to improve scalability of intrusion detection and also detection with advanced threat with increased precision, also federated learning and response through privacy preserving information sharing. Then the fourth one is standardization of data and knowledge about incident response and recovery, and local response recovery based on global knowledge in time. Also outsourcing the threat handling for small and mid-sized companies, and finally increase the interoperability of threat intelligence with advanced visualization techniques. So the SAPPAN methodology can be divided into few phases. So first one is stakeholder assessment, and where we are contacting CSRIT and industrial members and to outline how impact use cases. Then in the concept development, we are identifying common aspects such as what is relevant for the stakeholders and propose algorithm for fast data processing and propose privacy preserving algorithm. And the next phase is framework design, where the overall system architecture is considered, and we see how this can be built on top of top of and integrated with some existing tool sets. And the fourth phase is implementation phase, where we want to develop technology solution to support different tasks, and in particular related to response and recovery and automation. In the evaluation phase, SAPPAN technologies will be tested in relevant environment across several organizations, and we would like to do performance tests as well as functional, where we'll collect feedback from the security experts. And in the exploitation set, we'll ensure the developed solution not only complied with user requirement but also feasible from business perspective. So as you see, the a typical cyber incident response and recovery lifecycle can be divided into 4 stages as preparation, detection, assessment, and handling. In SAPPAN concept, our main focus is on detection and handling. Here we can see the SAPPAN concept. Here on the left side, we look at the local response and recovery, where there is a cybersecurity data is collected and processed, and it is locally detected, and also in the response and recovery section, it is done at local level. And all these local steps can be converted to can be shared to a global level with a SAPPAN sharing platform. And in the global level, it will enable federated learning and improved detection, and also improved response and recovery actions. And how the work packages are related here. Work package 1 and 7 are mainly consortium management and exploitation and dissemination work packages, whereas work package 2 is related to use case and requirements. Work package 3 is related to the massive data acquisition and detection at local level. Work package 4 considers response and recovery actions and automation and standard and formalization of different playbooks. And whereas work package 5 considers threat detection in federated fashion, also sharing response and recovery action. Work package 6 is considered the SAPPAN demonstrator, and also the visualization of the SAPPAN demonstrator. And note that each work package includes also a visualization task. So as I already said, there are the details of the work packages. Work package 3 is message data acquisition. Work package 4 is managing and automation of threat intelligence. Work package 5 is the federated feature and sharing of cyber threat detection. Work package 6 is integration and validation. And we have few milestones. Milestone 1 is use case definition, and milestone 2 is data selection and preparation, and these 2 are already achieved, and we have the later 3 milestones will be achieved in the upcoming months. So as you see the current progress, the project started from 2019 May, and we have submitted the respective technical and administrative deliverable to EU. And in beginning of 2020, we had the first interaction with SAPPAN Consortium and in Helsinki, and it was very insightful and a very successful event. and we're happy to collaborate with SAPPAN Consortium again in ARES NG-SOC workshop, and looking forward for more future collaboration. And finally, we are the coordinator of SAPPAN project. We are the data protection and sovereignty group from Fauna for Fit. And if you have any question regarding SAPPAN or want to have a future collaboration, please contact me, Avikarsh Mandal, or my colleague Benjamin Hackman. Thank you very much.